My name is Viveka Vaughn. I am an associate professor of mathematics and a member of the COE Steering Committee. I'm joined by my colleagues who are also members of the COE Steering Committee, which is chaired by Drs. Lisa Winfield, Division Chair for Natural Sciences and Mathematics, and Dr. Sandra Patterson, Division Chair for Social Sciences and Education. The 7 faculty from these 2 divisions who are serving on this leadership body with me are Dr. Marilyn Davis of Political Science, Dr. Valicia Ellis, Education, Dr. Nataki Osborne-Jokes, Environmental Sciences, Dr. Shanina Sanders Johnson, Chemistry, Dr. Celeste Lee, Sociology and Anthropology, Dr. Alethea Tillman, Biology, and myself. Many of you may already be aware of this statistic, but Spelman has consistently been the top producer of Black women who advance to earn doctoral degrees in STEM fields. All right, that deserves an applause right there. It is because of this stellar track record that the Department of Defense deemed Spelman a center of excellence for minority women in STEM and provided seed funding. The mission of the Center of Excellence for Minority Women in STEM is to be an exemplar for the nation as we equip, empower, and elevate women of color from historically underrepresented groups in STEM to thrive and lead. We appreciate you all, and we thank you all for joining us today for our final session of the Women in STEM Speaker Series of this academic year. The Women in STEM Speaker Series was designed to celebrate trailblazing women in STEM. Each academic year, we select a theme. As you can imagine, back in 2020, the theme was COVID-19. In 2021, the theme was Spelman on the front lines. And now, this year's theme is STEM Excellence at Spelman. In today's session, we are honored to have our inaugural Faulkner Scholar in Residence, Dr. Candice Price, to present. Before we bring Dr. Price, we will have one of our Department of Defense scholars, Ms. Layla Hayes, introduce Dr. Price. Layla is a graduating senior this year in chemistry, and she is currently working on a 2nd degree in biomedical engineering at Georgia Tech. Please let us welcome Ms. Hayes.
Can y'all hear me? Okay. Dr. Candice Price was born in Long Beach, California, and raised in Sacramento. She earned her bachelor's degree in mathematics from the California State University, Chico, her master's in mathematics from San Francisco State University, and her doctorate from the University of Iowa. She is currently an associate professor at the Department of Mathematics at Smith College and is the inaugural Faulkner Scholar in Residence at Spelman College this academic school year. Her research area is primarily in DNA topology, and she is currently working in various areas of mathematical modeling. She is the director of the MAA Tensor Summa program, a co-director of the Mathematical Science Research Institute undergraduate program, a co-founder of the website Mathematically Gifted in Black, as well as the co-founder and co-CEO of 619 Reth Publishing, LLC. Her service mission is to create and contribute to programs that broaden the participation of groups that have been historically and systematically excluded from mathematics by focusing on strong mentoring and research networks. Let us now welcome our speaker, Dr. Candice Price.
Thank you. Thank you so much for that great introduction. It's a bit ironic. I almost wore that exact same outfit, so that would have been something else. Okay, great. So let me switch over to my slides. Okay. All right. Can everyone hear me? Okay. One of my hopes for this talk is it's going to be a bit interactive. One where you're going to turn to your neighbor and talk to each other about several things. So feel free at this moment to move a little closer to someone else if you feel like you might be a bit far from someone you could talk to. Feel free at this moment to move a little closer if you feel a bit far from someone you'd like to talk to. Okay, I like what I'm seeing. Seeing some movement. Nice. Thank you. Thank you. Introduce yourselves. Ask how their day is going. It's Wednesday, right? Okay, that's enough. That's enough talking. That's enough. Okay, what have I done? All right. Okay, thank you so much. Hopefully you enjoy the interactive parts. I know I will. So anytime I give a talk, I like to do acknowledgments. I have 3 acknowledgments that I would like to start this talk off with. The first acknowledgement is a land acknowledgement. This one I give at every talk that I am presenting. What's important for me as a descendant of enslaved Africans is to think about the land that I live on, the land that I have a privilege of living and working on, and the indigenous groups whose land that this really belongs to. It also lets me remember that this space, this land that we're on takes care of me, and I have to think about what I'm doing to take care of the land. So it's always important for me to include that. So I've included the Smith land acknowledgement, and then at the bottom and then above, a very similar land acknowledgement that I wrote that includes the land that Spelman College is on. So that's quite important for me. The other acknowledgement is I really want to acknowledge the person that my fellowship is named after, Dr. Etta Faulkner. It's really hard to describe the impact that Dr. Faulkner has had on my life, seeing as how I never met her. But the impact that she had on Spelman College touched my life in various ways, and I didn't even know that it did. Many of my friends and mentors that are Black women in mathematics were impacted directly from Spelman College. Many graduated from here, many were EDGE fellows, which was funded or started by a Spelman faculty member. Just a lot of really wonderful, amazing things have happened because of this woman. And so it's important for me to acknowledge that I'm so grateful to have this title, to have this position, because it's a lot of shoes to fill, but I'm always so inspired when I hear of her story. I'm also really good friends with her granddaughter, and so it just makes me feel like now I'm part of the family. I spent Christmas with them. We played Black Card Revoked. I can't tell you any stories from that, but it was awesome. Okay. And then the last one is a bit of a new one. So I'm going to talk about some serious social justice issues, and I'm going to talk about the mathematics behind it. Some of my words may feel callous because I'm not talking about the issue itself. I want you to know that I definitely acknowledge that these are heavy issues. As someone whose identity is in intersections of those that are marginalized and those that are marginalizing, I know that it is very important to acknowledge that these are issues that impact people. I want to talk about the mathematics and how we can use it as a tool to talk about that impact and to see that it is systemic and not by accident, right? How does the mathematics help us do that, right? Because many of these things we know in our bodies are systemic. How do we use the mathematics to show it, okay? But I do want to acknowledge that some of the words I'll be using or the way that I'm talking about it might seem like I do not care. These are very important issues to me as well. All right. So before we dive in, just some definitions, right? Get us all on the same page. Social justice, I'm using the definition that social justice is justice in terms of the distribution of wealth, opportunities, and privileges within a society. That's what I'm considering social justice. Mathematics, the dreaded M word, is an area of knowledge that includes the topics of numbers, formulas, and related structures, shapes and the shapes in which they are contained, and quantities and their changes. Okay, so this is mathematics. So there's going to be different mathematical topics that I'll talk about in this presentation. But I'm going to focus on mathematics and social justice, and I'm going to focus on the intersection in two parts: mathematics as a tool to understand social justice issues, and then mathematics and the access to mathematical understanding as a tool for social injustice. Okay, so the first part we'll talk about some social justice issues, and then after I'll talk about math as a social justice issue. Okay. First, though, I want to start by telling you a story about a mathematician. Okay. I'm going to ask you to use your imagination here. If you need to shut your eyes, this is a safe space for that. Okay, I think. I don't know who you sat next to. I know I forced you to move, but okay. And in your head, I want you to picture a mathematician. Okay, I want you to picture the setting of this story as well as I go through this. Okay, so in your mind, picture a mathematician. Okay, please hold that picture in your head. It'll be important at the end. Well, later, I should say, probably at the end of the talk. All right, so the story starts here. In third grade, this mathematician learned how to multiply. Now, the way that they learned how to multiply was through rote memorization, right? It was like 3, 6, 9, right? 12, 15, 18, that's awkward. My brain just wanted to stop right there, right? So they memorized it in those ways, 2, 4, 6, 8, as opposed to understanding that mathematics or multiplication is this sort of like irritative, words are hard, is multiple addition, right? Like these clumps of things. Thank you. Everyone is nodding. I appreciate it. All right. So the multiplication that they learned was through memorization, through song. All right. And so they were very excited because they loved music and they loved this combination of mathematics and music. They were so talented in mathematics that they were allowed to skip a grade in the 4th grade to 5th. Okay, so what they learned is that this mathematical ability allowed them to go further in their education, to open doors for them that they didn't know would be opened. One of those doors was they got into a humanities program in high school, and so they shifted their focus from STEM-related things, calculations, mathematics, to humanities, and started thinking about humanities issues. Another thing that happened during high school was that this mathematician lost their love of mathematics. They took some hard courses, likely algebra, where all the numbers turned into letters, and no one explained how that can happen, and they got a bit confused and decided that maybe they're more of a humanities person than a STEM person. In their undergraduate, they took a pre-calculus course, and their pre-calculus instructor said, hey, you know, you're pretty good at mathematics. You should think about doing this as your career. And never before had anyone said to this mathematician, you're pretty good at mathematics. This might be something that you want to do. So they went with it. They said, okay, I will continue with this because I used to really love it. Maybe I can find that joy and love of mathematics again. They got a master's, on their way to a doctorate, and then they got a PhD. This PhD that they got was far from home, right? So they struggled a bit. It was really rocky, but they found a community that would really support them at this PhD, and they succeeded. And during their postgrad, they moved around quite a bit, just trying to find a perfect fit for them. But we all know that there's not going to be a perfect fit, so they found one that was good enough at the time. Okay, I'm going to ask you, who is this mathematician? Who did you picture in your head when I asked about this? Okay, does anyone feel comfortable sharing who they think, what they think this mathematician looked like at the start of this story? Yes, please. A man. Just a man, like Invisible Man, or what did this man look like? Yeah, okay. I appreciate that you said that. We're going to talk about that right now, but the big reveal is it was me. Who knew? Who knew I was talking about me? Okay, put your hands down. Yeah, it was me. So this is my story, right? I didn't leave any of the schools in there because of my introduction. It was hard to like edit this in a way. But that is my story. There was a period of time where I wasn't sure that this was the space for me. And I think that one of the issues is that access to mathematics was sort of taken away from me at some point. I didn't think it was for me. All right, so I definitely wanted to share with you my story. I also want to share why I'm interested in math and social justice. My visible identities as a Black woman, right? Social justice issues are really important. They impact me, probably us, more heavily than other people in our community, in our society. My invisible identities, I'm first gen, low income. There are lots of social justice issues that impact that part of my identity. And also my students. Many of the students that I teach are also part of this community, these communities that are heavily impacted by a lot of different issues. And what's important to me is that they want to know, how do I use mathematics to change things? Okay, so I'm curious also, what would I need, what do I learn in order to support? So a couple of projects that I've worked on. One is I wrote a paper utilizing social network analysis to study communities of women in conflict zones. And this was a paper that was inspired by a call. One of my previous positions was at the West Point, the military academy at West Point, and they had this call for papers about how to support women in conflict zones. And so myself and another colleague, we got together and we thought, what can we do to talk about this issue? And so we were inspired by the movie Pray the Devil Back to Hell. And this movie is a documentary about the women of Liberia Mass Action for Peace. And what they did was they combined forces, these women from different groups, worked together to force the community members who were in charge to start peace talks. Okay, this documentary was amazing, but the idea is that we were interested in the network, the connections of people, to find out, how do you create or how do you support a network of women who want to change their community? And so what we looked at was a social network model. So in this picture, each of the black circles are people, and each of the lines are some connection. Whatever we've sort of decided, maybe familiar, maybe same religion, maybe same neighborhood, same school. And what we thought about was, if we were to look at this network, who are the people we should share information with? Meaning, who's most connected so they can share the information across the network? Who are the leaders in these groups, right? Who are the people who are connecting clusters of people, right? With work like this, it's very important to make sure that you're utilizing this data in a good way. This isn't data that we would want to maybe share with opposition, but it is data that we could use to support these communities. Okay, so I put up a very simple social network model, but you can imagine it probably looks more like this. But I just think if I had put this up first, I think people would have left. And I like having people to talk to, so I didn't do that. Okay, the next project that I really enjoyed working on was a project on gerrymandering. And so what gerrymandering is it's a redrawing of districts in a state, in a city, voting districts, such that you draw it in a way that it disenfranchises one group. So in this case, we have 6 districts, right? And each district has 7 houses. And so it's equal number of blue houses, equal number of red houses. And the way this district is drawn, 50-50. Kind of what we would think is fair, right? I think we all think fair is 50-50. But one thing that can happen is I can redraw these districts in such a way that blue overwhelmingly wins. They didn't change the number of houses that were blue, but they changed the way the lines were drawn. They did something called cracking, where they split up red houses, and they did something called packing, where they packed red houses all into one space. Okay, so this is what we would consider something gerrymandered, where we are disenfranchising red houses. So mathematics is a tool used in gerrymandering, right? We have to understand the mathematics behind how many houses need to go where should I draw the lines, things like that. So I was a part of a group that asked the question, well, if mathematics is used as a tool to gerrymander, could we use it as a tool to show that there's gerrymandering happening, right? Because gerrymandering is actually illegal. You're not allowed to draw districts in such a way that you disenfranchise people based on race or based on partisanship. So I was lucky enough to go to this really great workshop that talked about how to measure gerrymandering. One of the ways is with geometry. And so the question is, if I look at the curvature after I've folded along all the lines that were created, this is probably like the newest thing that people are doing, and I see something that is negatively curvature, it's negative. So we'll say that something has positive curvature if it's like a circle, like a sphere. And we'll say something is has negative curvature if it's more like a saddle, right? Like goes down and goes up. Is that, okay, thank you, yeah. I'm glad I did this, yes? Does that help? Okay. So if we fold across these district lines and we create a shape, like origami fold, a shape that has negative curvature, this is a sign that this is a gerrymandered district. So this is a new sort of work that is happening with gerrymandering. The other is using statistics. If we look at all the possible ways to draw these districts, and we see that the probability of drawing a district that has the results that the district that was drawn, the results that we get is low, some threshold, then we can tell that it was not on accident, but it was done on purpose to disenfranchise a group. Right? These are the two tools that I learned at this workshop. Really cool stuff, but what really interested me was that while we have voting districts, we have districts for a lot of things. And one of the things we have districts for are organ donations. So this is a regional map of organ donations for liver. This is liver allocations. So what this says is if you live in, let's say, region 8, and someone passes away with a liver, and if you're at the top of the list at region 8, you're in line for that liver. But if you live in region 8 and someone passes away in region, I should look here because I can't even see that, 5, you're not on that list. You're not allowed. Wrong district. So the question is that fair? What does fairness mean in this case? Is it equal opportunity? Does everyone have an opportunity to get a liver when needed? And so what's very interesting is things have changed since I started looking at this problem. The corporations or the groups that are in charge of this, UNOS, which is the United Network for Organ Sharing, and the Organ Procurement and Transplantation Network, OPNTN, they came together and they decided, we're hearing a lot of information that this is not as equitable as we'd want. How can we change it? And so what they've done is they've gotten rid of districts and started thinking about how close people are to different donation hospitals, different hospitals that can actually do transplants. And so this is huge because they have taken away this barrier of someone living in, say, Colorado, really close to Utah, and just being maybe 10 miles away from a hospital and not being able to get that liver, all right? Now the question becomes, is this still equitable? Is there something more we can do to make this a bit better? So mathematicians have been talking about this and using the idea of redistricting, gerrymandering, the mathematics behind it to find out whether or not decisions being made are actually supporting the people it's supposed to. So I really enjoyed these two projects, and I wanted to talk about those, but I also wanted to talk about with you ways that you can also think about the mathematics behind some social justice issues. So this is kind of where the interaction part happens. I know you've been sitting there for a while and you're like, she promised to be interactive. She's just talking to us, showing these slides. We don't care. Okay, interaction. All right, so there's lots of options for discussion, and I had a really hard time deciding what to do, so I wanted to do a little choose your own adventure here. We can talk about water as a social justice issue. We can talk about education as a social justice issue, or we can talk about voting as a social justice issue. Okay, so I'm going to have you vote. All right, now the way we're going to vote is we're going to use poll everywhere. All right, so this is where the poll will be. I have to activate it. I'm just showing you this so that, okay, let me get to it. I'm sorry. I didn't plan this out well. Oh, yeah, I did want to do like a practice. Oh, well. All right. Let's see where we're going. Do you want to be surprised, or you want me to show you the results as they come in? I'll show you. Oh, surprise, okay. All right. We got one. Okay, can we all still see how to get there? Does anyone need to see that differently? You can like raise your hand or nod. Don't nod, I won't be able to see you. But blink twice. It was a joke. It was a joke. Just trying to liven it up. Ooh, 23. It's good. I think there's about 400 people in here. I'm not really good at estimation. It's not my strong suit, but. It's more than 36. 40. Sometimes in my previous classes, I'll do poll everywheres, and then 10 out of the 40 will answer, and then I'll be like, let's get a few more, and then one person will, I'm like, perfect, just crying. So if you're in a class and your instructor is doing poll everywhere, be that person that does it, because we are excited about hearing what you think. Okay, has anyone not gotten the chance to answer that wants to answer? Yes, is your hand up, or you're just, okay, I'm sorry. Okay, see, I turn back and there are 46. All right, are we ready? Ooh, water. No one wants to talk about voting? Rude. Okay, so let's talk about water. Now, I thought that this might happen, right, where we'd have education, or water, or voting. Okay, so what I've done is at the end of this presentation, there will be a QR code that has a YouTube video of me going through all of them. Okay, so if there was something you were like, I really wanted to know what she was going to say about this, you can listen to me talk to myself in my office. Okay, so that'll be there. Okay, I wasn't sure I was going to be able to do that, and then I did it, and I was very proud of myself, and then I passed out. So, oh yes, if you were clapping, thank you. Oh, thank you, thank you. You could do that throughout the whole thing. That'd be great. Okay. So we're going with water. Oh, I don't want to start from the beginning. Oh, because I clicked on the wrong thing. Awkward. All right. Was it TLC? Is that what did it for you? Yeah. Pardon? You know what? Thank you. Thank you. I like them. They make it fun. All right. Here we go with water. So what we're going to do is what I'd like us to take a look at are some headlines about water issues, and then talk about what is the mathematics that we could utilize here to answer questions that we may have, all right? This is where the interaction part comes in. You're going to talk to each other about these different headlines and things like that. What I'll do is I'll do a few of them, and I'll just talk, and then I'll give you the one that you're all going to talk about, just to, mimic what we're supposed to do. All right. So Water as a social justice issue is a global issue. It's a global issue. So reckless water use is spawning a global crisis. There are many places on this earth that are impacted negatively by water usage, too much water, too little water. All right. And so even in fact, there is a national or global water day, a World Water Day. And we actually just had it. It was March 22nd. And at World Water Day, I want to share with you some really striking data that came out of that. And I will stay in front of the mic, so I'm not whispering to myself up here. The theme this year was water and climate change. 1.4 million people die annually, and 74 million will have their lives shortened by diseases related to poor water, sanitation, and hygiene. Okay, that's global. Today, 1 in 4, 2 billion people worldwide, lack safe drinking water. Almost half of the global population, 3.6 billion people, lack safe sanitation. Globally, 44% of household wastewater is not safely treated. And then the United Nations Children's Agency, UNICEF, says that on the continent of Africa alone, 190 million children in 10 countries are at the highest risk from a convergence of 3 water-related threats: inadequate water, sanitation, and hygiene-related diseases. So this is a global issue that we can see. And in fact, we've seen recently 2 very big issues that have happened. So one of those is this idea of day 0. The city is counting down the days until its water taps run dry. This is Cape Town. So in 2018, Cape Town almost reached its day 0, meaning where it had no water at all. And in fact, what we're noticing, we as global we, is that the whole country of South Africa will have a problem soon because it relies on rainfall. Rainfall, which is not always constant, right? It's not always something that you know is going to happen. And also because of climate change, drought is what they're seeing. What we see in the data is that by 2030, if there is not some big plan, the whole country will have a day 0. The whole country of South Africa will run out of water. Now they're putting 60 billion, I'll always say American dollars because I don't know how to translate it, but they're putting $60 billion into this issue, but changes have to happen. So mathematically, what we can think about is, while we have this money, what can this money do, right? What are the questions we can ask? We have this money, we need rainfall. What are some other things we can do? Should we change agriculture, right? Should we get money or water from the ocean and start working on desalting, right? Things like that. So mathematically, questions that we have to ask ourselves are, what can we do with this money? Also, what else do we need to do? How much water should people be using every day? When I was a child, I think in California, lots of droughts in California, they told us you couldn't shower more than 2 minutes. I may have made that 5. Was it 5? Okay, thank you, California people. I was at 2 minutes, like, oh my gosh, that's a lot. And you had to I learned how to brush my teeth by turning the water off every time. My mom doesn't do that, she's from New York. I'm like, why are you just wasting water? It's a rough life when we're together, okay? So what sort of mechanisms do we need in order to support South Africa, right? What does the data say? The other one is this big question about floods in Pakistan. So very recently, there were floods in Pakistan. And what has happened is that 10 million people lack safe water 6 months after these floods. They were devastating floods. Pakistan, billions of dollars worth of damage, but on top of that, it has negatively impacted the lives of people. They are out of water, and so what they've resorted to is drinking the flood water, right? That is leaving them open to many different waterborne diseases, right? So what can we do to help, right? What does the data help us figure out in that case? How do we get water to these spaces? How do we get rid of the flood water, right? These are all sort of mathematical questions that we can ask. A little closer to home, right? We are not immune from water issues here in America, and some of our communities are more impacted than others. You may recall that Jackson, Mississippi had a huge water crisis recently, where Jackson residents were lining up at distribution points to get bottled water. And the reason that this happened was because flooding had caused the O.B. Curtis Water Treatment Plant, the city's largest water treatment facility, to shut down, stopping the treatment of drinking water indefinitely. So 150,000 people were impacted by this. And then we have Flint, Michigan, right? And it's wild that this is still a story that we are talking about, because it didn't need to be this way, right? What happened in Flint, Michigan is just wild. So the question is, how do we help? How do we help these areas? So what we're going to look at is this statement here. Walmart, Coca-Cola, Nestle, and PepsiCo came together and they said, we're going to provide Flint, Michigan public schools with water for students through the end of the year. They said, we're donating up to 6.5 million bottles of water for approximately 10,000 Flint public school students. Walmart also opened up a way that the public can support. So what I would like us to do is think about where the math comes in for this piece right here. Donations will provide up to 6.5 million bottles of water for approximately 10,000 Flint public school students. What questions can we ask? What can we know based on those questions? Okay, what are we curious about? And let's think about this mathematically. So I'd like to give you a couple of minutes, like literally 2, because I'm way over. Sorry, I talk a lot. Just a couple of minutes, chat with the person next to you. What questions could you ask when looking at this? Don't be shy. Okay. I know that was short, but what's great about this is you can continue talking about it after I've stepped off the stage. Okay, right? That was my goal here. Does anyone want to share some questions they thought of for this? Yes? Oh, I was going to repeat it, but yeah, if you want to go to the mic. Oh, okay. Yeah, sorry. If you wouldn't mind going to the mic, just to add a little bit more pressure.
There's a switch. Can you hit the switches? Thank you.
Sorry, I didn't know. I didn't know. Oh, perfect.
The first thing that came to mind was like, how are the bottles going to be allocated? And then and what I mean by allocated is like, are we talking about kindergarten, grade school, high school, or middle school? And then how would they break that up? Like, what is deemed as more important and less important, or where is like that whole spectrum? Yeah, that was the first thing I came.
Great question. Thank you. Great thoughts. Yeah. But you know you have to come to the mic.
I can speak loud. Is that good?
I don't know. I'm not in charge. I'm just, it seems like I am, but I'm not. Okay,
So
sorry.
one thing we talked about, so we divided 6.5 million divided by 10,000.
Mhm.
So that means that, assuming it's approximately 10,000 students, they would only get 2 bottles a day. So what does that mean in terms of distribution for the students? And also, which public schools, who's deciding which schools get to have water bottles and who doesn't?
Okay, so dividing, everybody gets 2. How do you decide who gets what? Thank you. Yes, yes. Sorry. I'm not in charge. I'm just trying to follow the rules. Don't want to get kicked out of here.
What's the size of the water bottle?
What's the size of the water bottle? Thank you. I know. It's good, right? Okay. I had some questions. I'm going to pull them up, but these are great. And I know that I didn't get to ask everyone. If I could, I would, but then people have stuff to do, I assume, right? It's Wednesday. I'm going to sleep after this. But okay, so how many public school students are there in Flint, Michigan, right? It says 10,000. Is that everyone? I think that was something someone said. Is that everyone? How much water does a person or child use every day? Is 2 bottles enough, right? Because if you think about what we use water for, everything. Yes, everything, right? You need water to use a toilet. Okay, sorry. How much water does a bottle of water hold? What size are the bottles? It just says bottles. Have you ever seen those? Could you imagine if they hand out those tiny Dasani? Oh. And we're all praising them. We're like, oh, look how great, 6.5 million. Like, oh, cups of water. How long will this donated amount of water last? How much water do you get at one time? Right? Do you get the full 2 bottles every day, or do you get all the water at the beginning that you then have to ration? What about everyone else? Right? Because if this is school-age children, what about babies? What about adults? Right? Things like that. So one of the things that I'm hoping that you can see is that when we read these headlines, it's really important to think about what does this really mean and how the mathematics can help us think about that. Because I think when a lot of people first saw this, they were patting Nestle, Coca-Cola, Pepsi, and Walmart on the back. Not literally, because that's weird, but figuratively. They're like, oh, look at them coming through. These are trillion-dollar companies, likely. I may have made that number up, but it's not recorded, so we're okay. These are companies that have a lot of money, and together they came up with 6.5 million bottles that they probably bottle themselves. Okay, so when we see these things, when we see these headlines, when we see graphs, it gives us an opportunity to think, what is this really saying and what's missing? Okay, this is how we can use mathematics for social justice issues. Now, as I mentioned before, it's choose your own adventure, so we're gonna stop here, but you can continue on this ride if you go to the YouTube channel after, and okay. So, we talked about mathematics as a tool to look at issues of social justice. Now let's turn our gaze to how math can be used as a tool for injustice. All right, so I want to talk about how mathematics access can be an issue for us. Now I want you to think back to how I started the talk with the picturing a mathematician. I truly appreciate the participant who shared their vision, because look at that. I knew it. I knew it. Do you want to know why I knew it? Because this is what I pictured for a very long time. This is what I pictured for a mathematician. And this is not by accident. This is by design, that we think that these are the people who are capable of mathematics, right? Every time I tell someone I'm a mathematician, they double take. Every time. And then they tell me how much they hate math, and I'm like, why are you sitting next to me on this plane? My headphones are in. I'm trying to ignore you, okay? I'm not even playing music. I'm not. One of the reasons why is because a lot of portrayals of mathematicians in movies are white men, right? And oftentimes these are people who have a bit of trouble or are not really enjoying math. And a lot of times math is sort of kicking their butt, right? And so it's this hard thing that only they can do, and they're saving the world with it, right? And until very recently, this was the picture of a mathematician. And it wasn't until 2016 that we got a change in that picture. When Hidden Figures came out, and it was a real story of real women that is wild that we didn't know, hence the title, right? This changed a lot of things. We got to see Black women doing mathematics, hard mathematics, right? Talking about mathematics. We got to see women fighting for their space to learn and not being afraid, going in there and knowing what they needed to do. We got to see women being in the front of STEM, right? They're changing to computers. They said, we're going to be ready when you change to electronic computers. When you need us, we're going to be ready. But not only that, we got to see Black women in STEM with joy, happiness, dancing, enjoying their life. And we rarely get to see Black women enjoying life on film. This movie had a huge impact on me because for so long I was doing this thing of mathematics without knowing that other people that looked like me were also doing it. It took a while until I met people, and I actually met those people here at Spelman at a conference while I was a master's student. This place has had a huge impact on my life, and this film as well. So when we talk about the intersection of math and social justice, access is really a huge part of that. And one of the reasons why we have trouble accessing mathematics is because we rarely get to see ourselves in those spaces, right? And so while we may think that we don't belong in those spaces, we definitely do. So as a social justice issue, one thing that we know is that talent is equally distributed around the world, but opportunity is not. It's important for us to think about that. We have the abilities, but sometimes we do not have the door. The gate or the door is closed to us. Bob Moses was a really great civil rights leader who started the Algebra Project in an effort to use math literacy as an organizing tool to gain economic and educational rights. He noticed that math illiteracy was pulling us back as a community, and he said, I'm going to change that. Math is never neutral. Math as a subject area is a reflection of the values and stories propagated by a given educational system's architect. It's not neutral. People have decided the stories we tell in mathematics. People are doing mathematics. Who are the people we're showing doing mathematics? And then we should be rehumanizing mathematics, which considers not just access and achievement, but the politics in teaching and mathematics. We need to bring back more humanity into the mathematical field so that everyone has access, so that everyone can have a conversation about mathematics, so everyone can look at these headlines and think, what are the questions I can ask? Instead of just thinking, this number is great, 6.5 million, look at them. Million is a giant number. So the questions now become, how is math political, right? Mathematics itself is not political, but it is always taught with a political and historical context. So the question is, whose political outlook, whose historical content is math being told through? People are political. People are teaching and talking about mathematics. With what lens? Like me right now, my lens is social justice, right? You should know that. There are going to be other people whose lens is math is neutral. It's important to understand that this lens, this conversation about mathematics is always coming from somewhere. How is math related to white supremacy is a big question. One thing that we can see is that the characteristics of white supremacy culture are very similar to the characteristics of mathematical communities. One of those being the need for perfectionism. It is impossible to be perfect because that line just keeps moving. Yet if all you're striving for is perfection, you don't get to enjoy the route that you're taking. You don't get to show the different ways you can get to the same place. There's always an urgency to get to perfect. And we also have someone deciding what perfect is. And it never is the person who's striving. How do we rehumanize mathematics? We do this by welcoming everyone and every thought, every path into the space. Why is this important? So here is a graph of the US population, and then the different percentages of, based on races, of getting associate degrees, bachelor degrees, master's degrees, doctoral. I think this is 2021. See, this is, I wanted to fit it on the slide, and I cut it off, and now I can't remember. That's awkward. And I didn't even write into my notes. Where it just, oh, what, where? Oh, that's awkward. Thank you, I did. I tried to get like newer data, that's why, right? And so I want you to look at this chart and see what it is telling us about certain groups in America. Even though certain groups make up about 30% of the population, where are they falling when it comes to different degrees? And then I want you to think about the economic basis of these degrees. Right? What kind of salary do you get with an associate's degree, bachelor's degree, master's degree, doctoral degree? I have to tell you that this is by design, right? Because the more of us reaching a goal, we like to move it further. So why is this important? Why do I care if you care about mathematics? Well, mathematics is everywhere, right? It has impacted our lives a ton. Francis Galton was a pioneered scientific advances in many fields, but he also founded eugenics. A scientist decided that the way that people look, their melanin, amount of melanin in their bodies, told you whether or not they were intelligent. Decided that. And people have used that for many, many years. Artificial intelligence exasperates racial inequalities. Facial recognition software is being created by people who don't look like us. And so what that means is if we're not in that space having those conversations, there's not anyone thinking about what will this do to this population. Racist and classist roots of standardized testing found a home at Stanford. If we're not in the room talking about the issues with standardized tests, and they're always used to see who can go to college, who can go here, who can do that, we have no say in what's happening. They need people who are computationally competent in those spaces to talk about what the data is showing them. I want it to be us. I mean, not me, I'm very busy, but I want it to be you. I will say that, you. But the royal us. Researchers use AI to predict crimes, biased policing in major US cities like LA, right? AI is used for predictive policing. Who's writing those algorithms? What is it saying about people who don't look like them? San Francisco gives approval for police to deploy robots with lethal capabilities. There's a lot of mathematics in how you program a robot. Who's the mathematician that's programming the robots that police use? What are they looking for? The NIH-supported study suggests alternative to race-based kidney function calculations. So this is a new one for me. So I am kind of addicted to TikTok. I don't want to talk about it. But I saw this TikTok, and it was talking about this equation. And so I wrote this down because I think it's very important that I talk about this formula. Okay, this formula, the estimated, oh gosh, I practice, I swear. But you know when you practice by yourself, no one's there to tell you you're saying it wrong. Glomerular filtration rate, or EGFR for short, which measures how slowly or quickly kidneys remove a waste product called creatine from the blood. The estimated formula included a race as a factor. This overestimated black patients' kidney function by as much as 16%, thus showing they were less sick than someone who is not black. It just said you're black or not black. And when you were black, it gave you this factor. The race coefficient for EGFR has resulted in black people having to wait an estimated extra 2 years before being eligible for a kidney transplant, or declining so much before treatment that they were no longer eligible for a transplant. Someone decided to include race in this estimation. There's this really, well, great is a strong word, but there's a very good book called Medical Apartheid, which talks about a lot of these things. Okay, highly recommend. So there's just so many reasons why we need to be in these spaces, why access has been taken from us and why we need to take it back. All right, and I hope that this has sort of inspired you a bit to do that. The other really big one is the student debt crisis. And so I had to add this one because I'm a little worried that this might be mine. And I'm not sure who I need to talk to, but if one of you was in the room trying to decide whether or not to push the button to make it 0, I want to just say, please make it 0. Because what? Why? This is almost $2 trillion. The questions we can ask here are, what could people be doing without this debt in their lives? How would this impact the economy if people didn't have to pay this? I know people would buy houses if they could, right? I know that I don't know what I would do, but wow, right? Okay, coming to an end. I know, I'm also very sad. I'm gonna leave you with this. Mathematics has impacted your life at every single step. But most importantly, if you think about the probability of being born and all the things that have to happen, it's not that kind of talk, so I'm not going to say what those are, okay? Math and not biology, okay? If you think about all the things that have to happen, you will realize you are a miracle. They say it is 1 in a quadrillion chance to be born. A quadrillion is apparently a 1 with 15 zeros behind it. This is new for me too. So what I would say is go out there, make a change, utilize this knowledge that you have, utilize this power to change these issues that we're having with social justice. Okay, just think about it. Miracle is an event so unlikely it's almost impossible. It's almost impossible. 1 out of a quadrillion? Amazing. All right. Thank you so very much for listening. Here is the QR code for the YouTube.
All right, let's thank Dr. Price again for that informative talk. And we have time for one, if there's one burning quick question, we have time, but also to end our Women in STEM speaker series, we have a nice reception out in the tent. So feel free, Dr. Price will be out there, so feel free, she's shaking her head now, feel free to come and talk with her as well and get some food, because there's food out there. But does anyone have a question before? Yeah, come to the mic, please, Delina.
I think you had a great presentation. You're also
thank
a great
you.
public speaker.
Oh, wow.
I just want to say that. Felt
All
we're
right,
connected,
thanks.
and I don't even know you, so that was cool.
Thanks.
I had a question about the Jerry mappings. Gerrymandering. Yeah, gerrymandering. That whole topic, was that like something you did for like a research project or something? I just wanted to know where you cultivated that idea, or like what made you even think of that, because when you brought up the math piece, I knew what it was based off of like when we learned about it in school, and it was always tied to like voting, and where the demographics kind of are unproportionalized in certain senses. So I wanted to know like where, because when you put the math to it, I was like, whoa, that's like a whole different
Yeah.
way of looking at it that I never knew. And I wanted to know where you got all of that from.
Yeah, excellent. First of all, thank you for that compliment. I was super nervous. I just need you all to know. Like, I was like really stressed. I almost didn't come. I'm just kidding. But yeah, so I was invited to do a summer school where they brought in mathematicians, computer scientists, geospatial scientists, lawyers, political scientists, historians, to actually talk about the issue of gerrymandering before the 2020 census. Because at the census, every single state that has more than one representative in the House has to redraw district maps. So whoever was voted in that year gets to decide what those maps look like, right? So we wanted to tell people it's important to vote because they're going to change these things. So that's where I learned about all the mathematics that I could do and connection, and it was really interesting because it's such a huge problem that everyone is involved. As you said, who knew math was in there? I talked about this with someone and they mentioned, well, it's not just voting districts, school districts are like this, organ donations, and I was like, whoa, organ donations? I had no idea how those worked at all. I had a student who came up to me and I was saying, did you know organ donation? And he was like, I want to know more about this because I want to know how this impacts my community. And so that's when we started doing that research. And this hits at a very good point. So at any moment when you're reading these headlines and you're curious about it, you can dig into it, right? Like if you're curious about what size those bottles were, there should be something there. And you can actually model how long did that water last for those community members? And what happened when it was all gone? So use your curiosity, right? Knowledge is finite, but wonder is forever. Utilize that. You can learn so much. You have so many skills. Thank you for that question. I appreciate it. Thank you. Thank you so much.
They don't give you the whole breakdown. They just tell you how much you use, and then just right. So then I look at it, me trying to be a mathematician. I look at all my usage every single month, and I said, oh, I never really go over this amount. Based on the rate that they're giving me, that times that is never going to make it to 80. So I'll be better off just paying the rate. What they don't include is whatever fees they use to transport the gas from through the pipes. But that's double it. So my gas bill is like double, and my usage has not changed at all. Well, you can get a fixed rate so that it's the same, like 65 cents per. It's winter versus what the rate was on all of that. I'm like, this is all bull. And they were like, additional fee. I told them, they were like, that's to get the extra. I said, that never came up on any of my bills last year. They were like, well, you were having a fixed plan. Yeah, but why? The gas company, they were like, yeah, that's the unit I had, but not the right gas. So I'm not going to do something that you're not going to get to me. No, you do, and that fee is based on your usage. So that's actually like twice. It doubles it. Yeah, I pay all the bills, but I'm like, please not. Turn it off. Put a sweater on. It's only 7 years, so yeah, it's like